Good day everyone. Here's our math challenge for today. If x raised to the fifth power equals 1, then solve for all values of the following expression. We have x over 1 plus x squared plus x squared all over 1 plus x to the fourth power plus x cubed all over 1 plus x to the fourth all over 1 plus x cubed. Now, if you want to try this problem, just pause this video right now, and if you're ready, here's the solution. And I hope you pause this video. Now let's see if you got the correct answer. To answer this question, we will use the available given that we have. So let's use x to the fifth power equals 1. Now subtract 1 on both sides, we get x to the fifth power minus 1 equals 0. Now take note that x to the fifth minus 1 can be factored nicely. If we factor this, we get x minus 1 multiplied by x to the fourth power plus x cubed plus x squared plus x plus 1. And don't forget that it is equal to 0. And since it is equal to 0, therefore, at least one of them must be equal to 0. So if x minus 1 equals 0, we get x equals 1. And this is our first case. Now the second case is if x to the fourth plus x cubed plus x squared plus x plus 1 equals 0. And to make it simple, let's say this case is when x is not equal to 1. Now let's focus on our first case. If x equals 1. Now let's focus on this expression. We have x over 1 plus x squared over 1 plus x to the fourth and so on and so forth. Now we know that in first case, x equals 1. Therefore, we can replace all x by 1. If we do that, we get 1 over 1 plus x squared plus 1 squared all over 1 plus x to the fourth and so on and so forth. Now, if we simplify these terms, we get 1 half plus 1 half plus 1 half plus 1 half. And 1 half plus 1 half plus 1 half plus 1 half will give us 2. Therefore, the value of the expression when x equals 1 is definitely equal to 2. Now the question is this the only value of this expression? Now let's have the second case. Now in first case, we know that when x equals 1, this expression will give us a value of 2. So we're done on this case. Now let's start solving the second case. When x is not equal to 1. Now since x is not equal to 1, we also know that x to the fourth plus x cubed plus x squared plus x plus 1 equals 0. And it directly follows that x is not equal to 0. Alright? Now since x is not equal to 0, we can multiply this equation by x because we know for sure that x is not equal to 0. Therefore, if we multiply x on both sides, we get x raised to 6 equals x. Now keep in mind that x raised to 6 equals x. Now again, with the same reasoning, since x is not equal to 0, it is safe to multiply both sides by x. If we do that, we get x raised to 7 equals x squared. Now we will use those values to evaluate our expression. Now let's take our expression again. Now what we're going to do is to make all numerators equals x raised to the fifth power. Therefore, in the first term, let's multiply the numerator and denominator by x to the fourth power. If we do that, we get x raised to the fifth power all over x to the fourth plus x raised to 6. On the second term, we need to multiply by x cubed on numerator and the denominator to make the numerator equal to x raised to the fifth power. If we do that, we get x raised to the fifth power all over x cubed plus x raised to 7. Now the third term, we need to multiply the numerator and the denominator by x squared. And the fourth term, we need to multiply the numerator and the denominator by x. So we have x to the fifth power all over x plus x to the fourth. Now, Take note that x raised to the fifth power equals 1. Therefore, all of this numerator must be equal to 1. Next, we said that x raised to 6 equals x. Therefore, x raised to 6 must be equal to x. And this x raised to 7 must be equal to x squared. Now, let's rearrange some terms, like this. Now, x plus x to the fourth power is the same thing as x raised to the fourth plus x. And x squared plus x cubed is the same thing as x cubed plus x squared. Therefore, we have x to the fourth plus x and x cubed plus x squared. Now, take note that the first two terms are similar and the last two terms of this expression is also similar. So, we can combine them. If we do that, we get 2 all over x to the fourth plus x plus 2 all over x cubed plus x squared. Now, we can factor out 2. Next, let's combine these two fractions. To do that, let's multiply the first term by x cubed plus x squared on numerator and denominator. And the second term, let's multiply x to the fourth plus x on the numerator and the denominator. If we do that, we get this huge expression. Alright? Now at this point, let's simplify the denominator. So let's multiply them. If we do that, we get x raised to 7 plus x raised to 6 plus x raised to 4 plus x cubed. Now again, take note that x raised to 6 is said to be x. So we can replace x raised to 6 with x. And x raised to 7 is x squared. So we can replace all x raised to 7 by x squared. Now rearrange the power of x in the denominator such that the power of x is in decreasing order. So we have x raised to the fourth power plus x cubed plus x squared plus x. Now, since we have similar fraction, we can now add the numerator and copy the denominator. If we do that, we get x cubed plus x squared plus x to the fourth plus x. Now, let's arrange the exponent of the numerator such that the exponent of the variable x is in decreasing order. Therefore, we have x to the fourth plus x cubed plus x squared plus 1. And this is the same thing as in the denominator. Therefore, we can cancel all of them. And we get 2 times 1. And we can multiply 2 times 1 in our head. This is just equal to 2. Therefore, in the case that x is not equal to 1, we get the value of this expression is also equal to 2. Therefore, if x raised to the fifth power equals 1, the value of this expression, x over 1 plus x squared all over 1 plus x to the fourth plus x cubed all over 1 plus x raised to the fourth all over 1 plus x cubed is definitely 2. And as always, we're done.